Hello everybody, back here today with another Minecraft video. Let's just hop onto the server. I have bad priorities and I've been playing a lot on this. We got a little bit of, oh, okay, you can see me. That's cool. So we know that mob farms are not my specialty anymore. I'm sorry for the horrible lag. I am trying to still figure out why, but I'm kind of running out of time here to produce this. And we're just gonna have to bear with the lag. Yeah, while there's not any lag on my end, it still appears that in the recording software that there is a decent amount of stuttering that is going on. So I really apologize for the lackluster quality. I'm gonna guide you through kind of how to set up your own server from what I've learned. Yeah, I've got a kind of a stupidly large base. Anyways, let's get right to it. Ah, there we go. All right, so here you can see server up over here. We have the log file, which censor this since it does have my IP address, and I don't want that out in the public. I mean, you're not going to really gain much by having my IP address, but I don't really want it out there in the public anyways. So here you can see we have the Minecraft server in a Docker container. We actually are running this Docker container on what's called Synology. I don't know if you've ever heard of Synology NAS. Fantastic NAS units, but the problem is that I'm not actually running this even on genuine Synology hardware. I'm actually running this on a Dell PowerEdge R510, which is not supported hardware, and I'm using what's called Synology with loader 1.03b on, and I'm emulating the Synology DS3617XS. And I'm running DSM 6.2.2-249922 update 6, which is the latest version actually. And to do that, I had to use the driver extension DS301617 extra.lmza 05 version half test. And I had to copy the kernel zimage and rd.gz from the DSM DS3617XS _ 24922.pat file, the original one from Synology's website, to the partition one on OSF mount. And then from there, our hardware is a Dell PowerEdge R510, and it is the 12 bay 3.5 inch large form factor 2U server. So on the front of it, which we'll go down and see it here in just a little bit, is we have 12 hard drive bays on the front, and then there's also 2 internal hard drives, and the 2 internal hard drives are where we are actually currently running the Minecraft server from, because those ones are SAS drives. And while a lot of this may sound pretty technical to you and you may not know what's going on, SAS drives essentially, well, with a normal SATA hard drive, you can only read to it or write to it. You can't do both at the same time. With a SAS hard drive, however, you can do both at the same time, which significantly improves our performance on a server where you may have multiple people sending data to it and also requesting data from it at the same time, which with a regular set of hard drives will be a little bit more difficult. And while I do have a 12 hard drive RAID 6 on the server, I have been having some issues with it, and those are due to Synology having a 12 hard drive cap. And since we have those 2 extra drives that are running the Minecraft server, the 2 internal ones, those ones are getting the patched files. On the front are not getting those patch files, and so it keeps throwing errors, which you were able to see originally. Over here to this. Yep, 2 of the drives are crashed, 5 and 7. It's always 5 and 7. We have 2 Intel Xeon E5620s, which are quad cores, so for a total of 8 cores, and that is on the Westmere microarchitecture, which is the Nehalem architecture. And we have 32 gigs of RAM physically in the server. Now for the Minecraft server itself, we only have 24 gigs of RAM allocated to it, but that is due to the fact that I still want to leave 8 gigs for Synology because this is also my NAS. Alright everybody, so over here is the server rack. This is a server rack that was donated to me by my high school's IT guy. They were upgrading and he gave me this rack. It's a sound isolated rack, which is very nice because while these servers in here are quite quiet, in the past I've not had as quiet of ones, and this was an absolute savior. So right here up top we have the Dell PowerEdge R220, which is just a 1U server. We have ESXi 6.7 virtualization server on it, and we are virtualizing an Synology installation on it. And then right here is the R510, which is where we have the Minecraft server on. Here you can see those 12 bays that I talked about earlier. Here are drives 5 and 7. As you can see, these are hot swaps, so we can just take them out while it's running and pop them back in. These chunk of blue ones right here go to the R510. These blue ones right here do not. And then we also have the 2 fiber cables that go to it, which these are in a failover, but I don't know if we'll be able to see this. Maybe not. Anyways, there's a little laser on the inside of those, and it is fiber optic. So yeah, this is the server rack. We're going to close this back up though and head back upstairs. Let's show you guys how this really works. So basically what it is we are pulling an image called ITZG / Minecraft server latest, which if we go over here to the registry, we can search for that. Essentially what it is this is the Minecraft server that we are the basis of the Docker container. Yes, it is a pre-made container in a sense, but there's still a lot of configuring that you have to do in the background. Anyways, so then here it gets put in the registry. As you can see, the actual container size itself is only about 1/4 of a gigabyte, so it's really not all that much. I have been challenging somebody on the server to crash it on purpose because I want to see what this thing can handle. So let's hop over to the other PowerEdge, the PowerEdge R220, and let's actually go through setting up our own server. This is the R220 here. As you can see, we don't have any of the drive issues because we only have 2 hard drives allocated to it, which are just virtualized drives, but I have passed them through to it. So from here, we are able to open up Docker, and we'll actually delete, so you can still see the previous Minecraft Java server on here, which was it, but we're going to go ahead and just delete it because we don't need it anymore. It's definitely way past, and we'll actually remove, well, we'll leave the files there so that way we don't have to go through and recopy those back in. Since we already have it downloaded, we would download it from the registry, then we go back to image, and we are from here able to do Minecraft server latest, and then we can create a new Docker container. So from here I'm going to rename it Java Minecraft, and then we do want to click advanced settings, and we want to enable auto restart, and then from here we want to add a folder, and we want to point it towards our Minecraft Java folder, and then we want to mount this as /data. And then from there, we can leave our network settings alone, but we do want to change our ports to automatically go to 255.65, and we don't really care about this one too much, but we will force it to go through 255.75. So 255.57.5 is the remote console port, whereas 25.56.5 is the actual port that the user connects to when they connect via Minecraft. And then from there, we just have to add a path variable called EULA, and we just put true. And from there, we want to change our RAM allocation to, we'll put 4 gigs towards it. That pretty much does it. So while you can see that this is pretty easy, now we're going to start up the container, and then from here we should be able to go back to Minecraft, and so you can still see the old server's up, but we are going to add another server, and we're going to just call this one the R220, and this one is we're just going to use our local address as I don't have a second port forward set up for it. So we're going to do 10.0.8. 192.168.14, which is the address of the R220 on my network. I have it set as a static IP. And then we're going to do colon, since it isn't on the default port of 25.56.5, it's on 25.55.5. We're going to put in 25.55.5. And then from there, we should be able to click done. And look at that. Now we're going to connect to it, and we should be able to join the server. And while I still have the resource pack or whatever, here you can see this is actually an old version of my base. Yes, there's been a lot that's been done. But you can still see that it is running decently well, minus the fact that you guys are still getting a lot of stuttering. So we have the server up and running. As you can see, it's pretty easy. It took a while to figure out initially how to do it, but after you've done it a couple times, it really isn't that bad. The easy part is downloading the Docker container and getting it set up. And it went pretty smoothly because we didn't have to do any of the initial setup of putting in all the server config files, which I can show you here, those too. From here, you have to put in who you want as ops, so you have to put in the usernames and stuff like that. And then there's a lot in the server.properties file, which I won't dive too much into because. And then from here we can go to go, and we can do connect to server, R220, which is 10.0.8.14 on my network. And over here I got to authenticate really quickly. And then from here, I'm able to, I select the volumes that I want to mount, and I have Docker as a shared folder on the network. And then from there, I'm able to click mount, and then it pops up with that same folder that we were looking at earlier. So from here, we go to our Minecraft, and we go into our Java folder. And then here we can now see our server.properties file. Here we are able to see, so this is the spawn protection. This is how many chunks will always stay loaded. And then we have basically a watchdog timer that's built into the server of, hey, if the server takes this long to respawn, we're going to consider it crashed and for it to automatically restart. And here we have that set to 60 seconds or 1 minute. And then we have the server port set to 25.56.5, which we discussed earlier. And then a lot of this stuff is pretty self-explanatory. Here we have our max players thing, so this will show the max player amount. On the R220, I have it set to 16, but I could easily run probably 60 to 70 players on the R510 because we have 8 cores of Xeon. Albeit they're kind of an older Xeon, but still 8 cores, and it's a Minecraft server. Here we are able to change the view distance. So this is the view distance that it loads for everybody. Down here is basically what shows up when we first connect to that service. That's all that fancy colored text. And then, so once you're done messing with that, you are able to use a special server icon, but you have to name it server-icon.png. It has to be a .png file. And you also have to make it 64 by 64 pixels. Hard cap. If it is not 64 by 64 pixels, it will not load it. And then the really cool thing about this is that this is the world folder. So what you do is you can actually put in just a regular single player world that you've played on single player and drop it into, you just replace the world folder with your world, but you have to have it titled as world. And from there, it will actually basically just turn that single player world into your server. Okay, so from here you were able to see our Unify dashboard. So this is basically how I manage my network. If we go in here, we're able to see my client list, which is all the devices that are connected to my network. I do look at this quite often because I'm kind of a weirdo. As you can see, we have the iMac server, which does pull a decent amount of data through. 1.5 terabytes in the past month has gone through the iMac. We are very data hungry here, which is why I have to have this complex network. Whoever's providing your DHCP on your network is probably your Wi-Fi router. A lot of the times the Wi-Fi router's address is just 192.168.1.1. and if you type that into the address bar up top, you're able to connect to it. But basically what we're going to be looking for is what's called port forwarding. And here we can see it's quite convenient for me. And what it is we want to allow any incoming connections that are searching for the port 2556.5 to go to the IP address of our server, which I have set to 10.0.8.16, which is the address of the R510. And we also want to forward the port. So what you can do is you can actually have people connected on a different port than 2556.5. So you can set it to 5,000, whatever you want. Just make sure it isn't a conflicting port on your network. I leave it as 2556.5 as I don't care to change it. And then what you're able to do is you're able to say, hey, I want it to stay the same port. So in this case, we have a stay the same port as forwarding it to 2556.5. But if I wanted to forward it to port, say, a different port, we could easily do that. So I could actually make the incoming connection appear to be 2556.5, but then the forward port go to like 6,000 something, and then that forwarding port, we can go back over to our server again. Here we could change the port settings to the local port being that same number. So if we wanted to change it to 4,000, let's say, we could change it to 4,000, and then we just have to update the forward port over here to also be 4,000. But the external port would remain the same. So in order to ensure that it's going to work consistently, you have to set a static IP for whatever device it is that you're doing. So you want to go back over to your devices, and here we can see we have my R510, which I have given the static port of 10.0.8.16, and this can also still be done within your Wi-Fi router. And then for me, it's pretty easy. I just click use a fixed IP address, and I put in the IP address that I want. Some other routers are a little bit more complicated than that, but it really isn't that bad. So there's one other thing. You also have to use a dynamic DNS client. If you don't really know what that is, you can look it up. Basically, what it is it's what allows you to have a web address and have it always point back to your home server. So I use a dynamic DNS service client called NoIP. We are able to see that we have one active host name. So here you can see that I have the dynamic DNS client, and that is basically connecting to my account at noip.com. And it is saying, hey, we're going to run a test. This is what our current external IP address is. And then it sends it to noip.com. And then noip.com then routes back to my external IP address. So it kind of takes out the equation of my possible changing thing. Who doesn't love this laggy horribleness? Kind of the ultimate goal of this project was to enable me, even through social distancing, to still hang out with friends. I think that's it for today. See you next time. Now I gotta sneeze. Alright, now that that's over,